about significant figures.
I learned about this last year.
Sig figs?
Sig figs. You don't want to learn about significant
I don't
figures.
remember what they were.
Because they have a little unit here about significant figures. It's just it's like it is important.
Well, just remind me like what it is. Maybe I can
It's like looking at a number. Okay, well, let's just.
That's all it does. I'm sorry.
No, it's cool. It'll take 2 seconds. So, yeah, a significant figure is something that it's a number that was taken from an actual measurement. Like you measure something, right? And it is determined by the precision of the instrument with which you measured it. Does that make sense?
Yes.
So, like, for example, you are doing this space between your hands here.
Yes.
And I could measure that with a ruler. See, you put all this stuff. How am I supposed to?
I know it's like right. I put my stuff here too, so it's completely.
You know, I could use this thing right there, right? And ooh, yeah. So that's 7, and then 6. That's like 13. Pretty much evenly, yeah. So 13 and 1/8 inch, right? We'll just call that 13.1 inches.
Yep.
And or I could get like a micrometer that had many, many little dots in between it, and I could get 13.146. Or I could just say, you know, this is a 5 by 8 card, and you can put that up, and I can be like, oh, that's about 8 and maybe a half, right? So maybe like 12, something like that. The number of digits that you're reporting is a reflection of how accurate the number how accurate the measurement was, and so, like in the number 7,300. These zeros aren't giving you actual information, right? They're not giving you actual information. It's the 7 and the 3. I know that's giving me actual information. 408. So there's 3 sig figs here. 21.5.
Oh yeah, it's like when the zero's like in between two numbers. It's
Right. Like these don't mean anything. These zeros don't mean anything.
Wait,
Why are
the zeros after like the decimal point?
Yeah, because I could have just wrote 18, right? But I was able to measure, the thing I measured it with went out to the hundredths place. Does that make sense?
Yeah, but I mean, like, it is just 18.
It is, but it's exactly 18 and 0 100ths, right? It's exactly 18 and 0 100ths. If I had something that was just like, had no markings in between, and I was like, that looks like about 18. I don't know how many hundredths it is. You know, it is not 18.01, nor is it 17.99. It is 18.00. Whereas 18, that could be 18.01, or it could be 17.99. I don't know. I don't have information. What I was using to measure it wasn't that accurate. Significant figures. We spent, I feel like, weeks going over that shit when I had you in chemistry.
Really?
Maybe it was one of the other chem classes I taught. I don't know. One year I spent so much freaking time on
maybe it was.
on sig figs it made me want to die. It was.
Wait, so why isn't it important, the 7,300? Why isn't
The thing is, you don't actually know.
Oh,
You don't actually know, right?
So if it was like if it was like 7,300.
Then there would be 5 sig figs. Okay. And if those zeros were significant, the only way to convey that they were actually significant is to go 7.3 times 10. Oh, no, I'm sorry. 7.300 times 10 to the third. All right? And then you would know that these would be blue as well. And there would be 4 sig figs to use what's called scientific notation.
Can you just put a decimal into those?
No, well, you have to put something behind the decimal, and then that would be implying there's 5 sig figs. How do you say there's only 4 sig figs? You know what I'm saying?
Oh, okay.
Yeah, does that make sense? Yeah, this is a tricky case. The only way to solve this is using scientific notation. If those zeros should be blue, not black. So.
And so why would it be for like the other two when the zero, when it's like 0.0 and then sig fig?
Because this number in front of it, it's not telling you anything. That zero is not telling you anything. It's just like, why am I not like in the number 7,300? There could be zeros out here too.
Yeah, but there's a point, so it's telling you like the place in which.
It just means that it's smaller than 0. Yeah, it just means that it's smaller than 0. So, for example, the real answer is put it in scientific notation. Only significant figures show up in scientific notation. You would never write this as 2.5 times 10 to the negative third, right? You would just write 2.5.
I remember this now.
Okay.
Mm-hmm.
Okay. Anyways, significant figures. I don't know. They go through this right now because the whole point of this entire unit really is practical applications of trigonometry. And practical applications means measuring shit, like going out in the real world and using this stuff. And what my intention was to loop us back to the damn flagpole and find out whether I'm getting duct taped to that bastard or not and getting pied. I don't know. I hope not.
The flagpole is like a curse.
The what?
The flagpole is a
The
curse.
flagpole is a totem. It's just a totem.
Oh.
We can find the meaning in the totem and leave it behind. Yeah. Okay. So I don't know. Do you want to go through this? I don't think so. You guys got it.
Yeah.
Yeah. Right. This is where I wanted to get. It's the concept of solving triangles, and it's this idea of like learning how to solve triangles. This is the like sort of last of the part of trig that we're going to do related to triangles, and then it moves into circular functions, which I don't know if we're going to be able to do or not. I love this class so much. I'm really going to try. The A&P class is going to be rough in the spring, but this one I'm going to try to hold to. I think I can fit it in. And like getting those circular functions, that's where the shit gets so super cool. But I want to do this because this is actually practical. This is something that you may use someday when you want to build some shelves or you want to like do any kind of thing, any kind of construction thing, or I don't know. It is practical. It's some practical math. So solving a triangle, and the solving a triangle relates to remember in geometry where they talked about what do you need to know a triangle? There was the side angle side, or angle side angle, or like 3 things. You need to know 3 things: or angle angle angle, or side side side. It's solving a triangle is we're going to give you 3 bits of information, and you're going to solve all of the little unknowns in the triangle. So, for example, it's good to start with a sketch. All of the triangles that we are working with have a right angle in them, all right? And a right angles, this is a small tangent that I'll go on, but one of the things that I want to get you guys to see, in the beginning of the year, I talked about how practical trig was, but I also talked about how transcendental it could be, and I want to give you a little bit of both of those things. I want to give you a little bit of both. Talk about it, like give you stuff that you can use, but also like open the door just a little bit into the blindingly bright and beautiful world, the universe that we live in that is described by some of this math that I would like to go through, but I know if I ran too fast, I would lose you. So we'll just crack it open. So the right triangle, we've talked about the unit circle. The reason the right triangle is so important It's because that a 90-degree angle is things that are at a 90-degree angle with one another are what are called orthogonal to one another. Orthogonal. That angle has a special name. It's called orthogonal. And the reason it's special is because when you have two things, if you were to imagine the relationship between two things in any kind of thing, if they have some sort of relationship to one another, if that relationship is orthogonal, they one does not affect the other at all. Okay, so imagine having a flagpole, and this is the ground, and we have the sun overhead, directly overhead. This flagpole casts no shadow. Whereas if you had a flagpole sticking out like this and the sun was coming directly on, it's going to cast some sort of a shadow. When you move into what's called vector physics, a vector is, like, so for example, this would be a vector. This line here would be a vector. It is, this, we'll call this x, we'll call this, or no, y, this is x. And this is some vector, and x and y is space. Maybe we're looking down on top of a plane. We're in a little like drone up here, and this is the x and the y on a road somewhere. And a car is traveling in this direction, all right? And the length of that vector is how strong it is. If it were to hit a parked car that is you're moving and you hit a parked car, this car is going to travel a little bit in the x direction and a little bit in the y direction. It's going to travel more in the y direction than the x because its projection onto the y-axis is greater than the x-axis. X and y have orthogonal relationships to one another. That's a little bit of a tangent. You don't need to internalize so much. The point in terms of solving a triangle is that one of the bits of information you're getting is that one of the angles is 90 degrees. All right? One of the angles is 90 degrees. So when you're solving one, make a sketch. Always make a sketch. Draw it out. Try to actually visualize what's happening. Label all the parts. Step 1. Make a labeled sketch. All right, and it's good to use, they use this convention that the length of the side, capital letters are the angles, small case letters, opposite to that angle are the sides. That's just the convention that they use. All right. So they want you to solve this right triangle, ABC, and they're giving you that A, this angle here, is 34 degrees, 30 minutes, just to be a pain in the ass, and that it's 12.7 inches, again, to be a pain in the neck. And they want the lengths of B and A and B, and they want the measure of angle B. All right? How would you go about doing that? What do you think? How would you go about doing that? Yeah, let's start with that. So how would you do that?
We have two of them already, so you can just subtract from one.
All right, cool. Does someone want to do that? We'll give Ashley and Lance Templin 2 points for each of that. And I'll just do the math for you. So it's going to be 65 degrees, 30 minutes, right? Yep. So B equals 65, 30.
Is that not just 65.5 degrees?
Yeah, if you want to put it in fraction. Yeah, and do a decimal. That's right. All right. So we still need A and B.
So you set up a proportion.
Okay.
Since you know what side AB is, that, so 12.7 over 90 equals A over 34 degrees, 30 minutes.
Okay, so Lance is doing it this way here. He's saying that 12.7 over 90 equals 34 degrees, 30 minutes over A.
Wouldn't it be opposite? That's right. So
Oh, yeah, sure. Equals A over 34 degrees, 30 minutes. What do you guys think? Let's just follow your logic. Huh? I don't know. Are there any other ways before I go through this? I mean, what he's going to make me do is solve for A, and then I can do the same thing and solve for B, and then to see whether it works or not, how would we test it? How would we test that? Yeah. Well, we could use the Pythagorean theorem, right? We could figure out what he had for A and what we figure out for B, and see if each of those squared actually equals this squared. But that's a lot of nasty math. And before we go through that, I just want to ask if there's any other ways to do it.
Yeah, there must be.
Yeah.
obviously, because this is what I was taught in public school, so that means that I was taught the terrible long way of it. So yeah.
Okay.
There has to be an easier way.
Okay. Yep. Well, we've been working on some stuff here, haven't we? Yeah. Mm-hmm. And what have we been talking about in trig? Sine and cosine and tangent. Yeah. So what is sine? Sine is y over r, also known as, SOHCAHTOA. Yeah, opposite over hypotenuse, so it would be a over c. And cosine equals x over r, or in this labeling, b over c. And tangent equals what? That is y over x, which is the same as a over b.
I'm thinking the way that I picked to solve it was for any triangle, right? That's how you solve any triangle, not right triangles.
Well, you wouldn't know the C equal. I mean, you would have to know both.
Mm-hmm.
So you just got lucky that you know 90, but it's 90 degrees. If it wasn't 90 degrees, you would have to, you know?
You want me to do some long math here? Should I follow out his method?
Mm-hmm. Can we keep going with this?
Yeah.
Well, as long as you have 3 knowns, that's what I'm saying. So you're given, really you're only given 2, and then you have the 90, so you have it.
Right.
If you're given 3 things anyway, I think you can solve it. That's how you solve it if it's not a right triangle.
So the tangent of theta equals a over b, right? Which means the tangent of 34 degrees, 30 minutes equals a over b. Yeah, yep. And we can look up what the tangent of 34. We can use your calculator, or we can go to our spreadsheet.
Oh gosh,
We
no,
didn't
thank you.
finish our spreadsheet.
I know, we never did. We can look that value up and find out what that ratio is.
I don't,
No?
well, no. I just, how, what, isn't it just gonna give you, like, I don't know, some, like, decimal number? How do you figure out, like, the fraction?
Mm-hmm.
Like, of what's A and what's B?
All right. Here, rather than fill the board with that stuff, let's just do this. So they do it with sine. They take the sine of 3430,
Oh,
and
that's easier. That's, yeah.
right?
That makes more sense.
Does it make sense?
Yeah. You can, okay.
And then we just solve for
So-
a.
Would you be able to do it like?
You'd have to involve c somehow.
So we couldn't do tangent. Because
You would have to compare the tangent value to a sine or a cosine value. You somehow have to involve 12.7 in there because you don't know. It's going to give you ratios, but you don't know whether the triangle is this big, or this big. You need this length, and so you're going to have to either use sine or cosine at some point. That'll give you A, and then you can just do cosine.
Dr. Feedback?
Yep.
I think I might have to go.
Okay.
I was supposed to be dismissed, but my parents never dismissed me.
Yeah.
So I may need to go out and stuff and dismiss me.
No problem. All right. And then the finding B is easy. We just do the math the way we did it before.
I feel like maybe I should get one for
All right. Mars Bisson will give you maybe 3. That was a good insight. Bye, Ashley. All right. Yeah, there are other ways we could have done it. I should have asked you that. But you could have found the measure of B first and gone off of ratios off of that, the sine or the cosine of B.
Can you go back to the drawing?
Mm-hmm. Yep.
You could have done the cosine. Is that what is this?
Yeah, we could have put in whatever this was going to be, 60 for 30, and used the trig functions around 6430, right? So it could have been, we could have done, what would that be? Cosine, no, the sine of 6430 equals B over 12.7, for example. Yeah. Or the cosine of 6430 equals what? A over 12.7.
So how did you get 64.30? That was from sine.
90 minus 34
Oh, right,
degrees 30 minutes.
right.
And that gives us B. All right. This is super convenient. This is pretty powerful. Our lookup table. Because that's all our calculators are. They're lookup tables. We pop in the value, and it's going to calculate what that function value is. But we calculated it. We have it in our lookup table. The calculators are more convenient than our lookup table. But they're doing the same thing. All right. Yeah. So what do we do? To maintain accuracy, always give the information, use the given information as much as possible, and avoid rounding off in intermediate steps. This is them coming back to the significant figures thing. All right. So how about this one? Who wants to take a stab at it? Man, tell you about plastic. Sitting on a chair. No. Yeah. Go for it. Get some points for Ravenclaw.
I don't even know.
Which house isn't even here today? Slytherin
Yeah, Slytherin.
isn't even here.
Hufflepuff.
Oh, or Hufflepuff, yeah.
I don't even know where to start. There's 2 Gryffindors.
Well,
Um,
we have a diagram, don't we? So what do we have? We have A and C, right? So what could you use A and C to find?
B.
You could use it to find B, right? Doing what?
The Pythagorean theorem.
Pythagorean theorem. That seems kind of nasty, but you could do that for sure. What else? What's another way you could do it? Is there a way to use trig to solve that problem? You're right, absolutely. We could do that with the Pythagorean theorem. Absolutely correct.
I don't like doing sine, cosine, and tangent, but that's
What's-
what you're asking.
It is. What is A and C? How do they relate to one another in terms of trig?
It's opposite and hypotenuse.
Okay. And so, relative to what angle? A. Okay, yeah. So it's the opposite and the hypotenuse relative to A. Opposite and hypotenuse can come together and make what function? Functions, I should say.
Sine.
Sine. So write that down. Can you write that down? Let's see what it is. Sine of A, put sine of A, capital A, because that's our theta, equals right. And now what do we do with that? Now what do we do? We would have to take what's called an arc sine, the inverse function.
Oh,
We just go backwards in our lookup table. We go backwards. We would divide 29.43 by 53.58. Get some nasty number. You've got a calculator there. Lance, do it.
I'm not sure how to use these.
Oh. Well, then you open your laptop and go to the class lookup table, the trig thing.
Can I just like do a Google search on it? I like a Google calculator.
no, he wants us to compare. So divide.
29.43 by 53. My guess is it's going to be 29 is a little bit more than half the size of 53, so it's going to be like about 0.6, maybe 0.58.
Or something wrong. 29.43.
Yeah.
Divided by 53.58.
58. What is it?
0.5492 and a couple other numbers.
5492.
721.
721. Awesome. Yeah, we'll round after we're done with everything. Okay. 0.54927 is what angle for sine? About. Are you at a lookup table there, Lance?
Yeah, how do I get there?
So, here's sine. Sine is, it's right in between here. Right? Here's 0.5 and here's 0.55, so it's in here, in between these two. It's, yeah, so it's between 30 and 35 somewhere. Like, maybe 33. You could take that and go to the Desmos calculator and just pop 0.549721 into the arc sine. Well, let's do it on here so we can see how it happens. Oops, no, wait, where is it? So sine -1, oops, -1, oops, of, what's our number? 0.54, read it out to me up there.
927121.
Okay,
Wait,
oops.
721.
7,
You said 7.
2, 1. Okay, let's make sure we're in degrees. There we go. 33.3 degrees. That's basically what our lookup table told us, right? So let's go back to this. And we can label that. We said 33.3 degrees or whatever it was. And now what will be the next steps, Sydney?
How do we do that without like a calculator? You have to have a
You'll need a calculator. Yeah, you'll need to use Desmos.
Okay, so you can't just do it with a calculator, can you?
Mm-hmm.
Wait, so how would you? So we got 0. We would just do the sine of 0.
You do the arc sign, the
So-
inverse function sign.
Right. Okay.
It's just asking the calculator to go the other way back through the table.
Isn't that, would that be, is it -1 divided by, or is it just 1 divided by?
So here, I'll show you how I did it.
Sine?
Let's look at Desmos. See what I did here? How I
It's raised
sine to the -1. Yeah, not the whole quantity, but the sine itself, the sine function to the -1 is the same as arc sine, or the inverse function. It's just telling the computer to look the other way through the table, right? Yeah. And the way I did that, you're cool with it? So you just do it like sine, and then on this computer I did a shift 6 caret top, the power thing, and then just a -1, and then you go back down and you type the value in. Okay, cool. All right, let's let Sydney chug through this. So what's next?
B?
Yeah, get some B. I bet you could do that in your head.
Big B, right?
I'm saying big B.
120. Oh, so for big, that's the angle, right? So you would like subtract. It's from 180.
Well, you can do it a couple different ways. If you're doing it from 180, which is what the 3 angles add up to, you'll have to make sure to subtract C, which is 90,
Yeah.
right? Or you could just say B has got to be 90 minus A, right? So what's 90 minus 33.3?
I can't do math in my head.
Okay, so what's 9 minus 3?
9 minus 6.
Yeah, it's 6. But it's going to be, so what's 90 minus 30?
60.
60. But we're taking a little bit more away, right? So it's going to be greater or less than 60.
Less.
Less, yeah. So it's going to be 50-something.
56.7.
Thank you. Perfect. So you can do it. 56.7. Write that near B. And now all we need is little b. And what are some strategies for that? There's I can think of a bunch of ways to do it. In fact, instead of just doing it, let's just name the ways we could do it.
I could do it this way.
You could do it that way, right? So that would be what? Just set it up without even doing it.
I don't know.
Help her out.
Wait, so what? So it'd be like sine of little b equals.
well, sine of no, sine of angles, not lengths, right?
Right. Wait.
Sine
so
of-
how do you do it?
Here, let me write different ways down.
Oh. Okay. Wait.
Oh, here we are. We just want something that involves little b, right? So we could do sine of 56.7 equals little b over 53.58. We could do that. We could also do the cosine of 33.3 equals little b over 53.58. Okay, that would also get us there. What else? What other ways could we get there?
So, can you can use any of the angles, right?
Yeah. So what else could we do?
Oh, the Pythagorean theorem.
Sure, we could do the Pythagorean theorem, which would be 53.58 squared minus 29.43 squared, square root of that equals b,
Why would you subtract?
because normally it would be 53.58 squared equals 29.43 squared plus b squared.
Oh, right.
This was doing it on the head.
I see.
Cosine 33.3 equals 29 over b.
Wait, you're saying cosine of this equals 29. Nope.
No?
Cosine would be 29 over. Cosine would be b over c, adjacent over hypotenuse.
Oh, okay. So tangent of
Yeah. Okay. Great. Let's do some tangent. Tangent of what? Sure. Let's do tangent of 33.3 equals what?
53.58 over.
What
No,
is?
B over.
29.
So remember, SOHCAHTOA. SOHCAHTOA. TOA is opposite over adjacent. There's no hypotenuse
So
in
it's
tangent.
29 over b.
So it would be 29.43 over b. What else could we do? We've got 4 ways of solving this so far. There's more. There's a lot more.
Relating to sine and cosine and tangent.
Yeah.
I guess you could do couldn't you do all of the opposite ones?
Mm-hmm. Yep. So we could do. What's the Yep. cosecant of 56.7 equals what?
53.58
Over b. And then this one we'll just say is secant of 33.3 is 0.58 over b. And then we could do the cotangent of 33.3 equals 29.43 over b. We're not done. That's 7 ways. There's more. There's 2 more ways. 2 more ways.
Those would be flipped. On the bottom left, those would be flipped, right?
Where?
Oh yeah, you just forgot to.
Oh, sorry. Thanks. Yeah, cotangent would be better, wouldn't it? It'd be easier to isolate. 29.43. Okay. So let me give you a hint. We took the tangent of this angle, which involved these two, We could take a different tangent. What else can we take the tangent of? B. We could take the tangent of B. What would the tangent of B be? Tangent of 56.7,
B over
29.43, and then this has a cotangent of 29.43 over B. All of these methods, all 9 of them, are valid ways of coming up with the answer. Okay? We're not going to go through them and actually doing it. That's what the book is for. Well, let's see what they do. How do they do it? So, you're a good sport, Sydney. Let's give you let's give you at least 6 for standing up there. So they do sine of A, and then the arc sine of A, and that's where they get the 33.32. Nice job. And then they just figure out what B is, and they use the Pythagorean theorem. But we could have used any of those trig functions. All right. 44.7. Okay. So the next little bit of information we need to make this practical is they try to define these terms, angle of elevation and depression. And angle of depression is not how you're supposed to feel after this. It should be more uplifting. No, they're using these terms because that's how the kind of language you would use to translate into the real world, right? So say you're standing somewhere here at X, this is the horizon. The angle of elevation would be like looking up at the top of a building or something like that, right? Or the angle of depression, maybe you're on a cliff and you're looking down at something. What angle, how far down are you looking? Always it's in reference to the horizon line, your line of sight. And this would be a negative angle, and this would be a positive angle. Does that make sense? So let's see where we're going here. Caution! Oh, I forgot to bring the tea upstairs. Caution, what does it say? Please read it to me while I make the tea.
Be careful when interpreting the angle of depression. Both the angle of elevation and the angle of depression are measured between the line of sight and the horizontal line.
Yeah, that's right. Sorry, I'm supposed to bring some to Jerry's pitcher. Sorry, Jerry.
Oh. Poor Jerry.
Should be fine. All right. So this is their guidelines for solving an applied math, an applied trig problem. Step 1, draw a sketch. Because damn, this stuff is hard enough as it is. Just draw a sketch first to keep your brain from melting, right? It's hard to keep it in your head. Always sketch it out. Label everything. Put all the information that you need on the side. And
Okay, sorry. Can we talk about the flagpole?
Huh?
Can we talk about the flagpole?
Yeah, we're getting there.
Okay. Yes.
Yes.
Oh,
That was so
can we
perfect.
please finish the flagpole?
Let's finish this slide first.
Okay.
All of this, that whole flagpole activity that we did, I sent you out there to struggle with that and come up with some crap numbers so that we could then do all of this trig, build a trig table, just so we can answer this damn question. How tall is the freaking flagpole? All right, it's like that. The whole semester that's what I've been working for, just the damn flagpole.
I think it's funny in that I don't know how often they send it out, but in the news, oh my gosh, what's it called? Like the school newspaper.
Does anybody else want the rest of this cookie? I'm not cookies.
You had that little part where you were talking about like us.
This school newspaper?
Yeah.
There's a school newspaper. It's a newsletter.
Newsletter, yeah.
Oh.
Putting in stakes and like measuring the flagpole, and they have that every single time it's put out. It's the same thing. The trig
The
class.
same picture.
Yeah, or like
The same
article.
source.
I never looked at it.
It's funny.
They need to check in more often.
Yeah. Well, that was like the first week.
I know. Well, all right. Use your sketch, write an equation relating to the things that you want to find out. And then solve your equation, check your answer makes sense. The freaking flagpole. How are we going to do this? How are we doing this, team? Come up with the plan. I'm not going to
Okay.
tell you how.
It's gotta be
So-
similar triangles, right?
I didn't just waste my time going
Oof.
through all that stuff.
Oof.
I gave you information
Okay,
that you
so-
need.
We'll know this for sure. We'll know this.
Yep.
We can measure that. And then we were like using the
Goniometers. Yeah.
And like I'm trying to find
We don't
the.
need to make similar triangles. We can do it
I was-
straight from that.
I like haven't written.
Wow.
Wait, Lance, it's written in your notebook.
Is it?
Our numbers.
Oh,
If you can figure out, I don't know. But
How would you do it?
so
we have angle, side, angle.
What do you think, Sydney?
So,
Are you getting frustrated?
no.
No? You're good? All right.
I have a toy X.
So can we like
Get up there. I'm
label
done
them?
for the day. It's you guys. This is planning session.
Didn't we put
Next
them in
next Thursday, you're going to go and measure the flagpole.
So this one would be big B, right? I just want to label them, right?
Yeah, label your, go do it.
And then this is little c. No, this is big. Wait, this is little c,
Mm-hmm.
and this is big C.
Yeah.
Okay. All right. So
What values can we measure?
We can get theta.
We can measure theta.
Definitely C.
Okay, so just write theta. So let's make some number up. Make some
Well-
number up.
wait, this is how we did like how Lance and I were doing it. We were measuring, like, we did this, and we have like the numbers for it in his notebook
Oh.
somewhere. So we're just gonna make something up for theta.
Or well, he can, pull the numbers out.
Do you have it?
I
Still?
don't know where they are, but I think we put them in some sort of spreadsheet, right?
No, we just had them in your notebook. But if you don't have it,
Yeah, just make a number up. Doesn't matter.
this marker is horrible.
I know. Where's the orange one? Did I stick it in my pocket?
Didn't we turn something in?
It might be on my computer case over there.
I don't remember. Oh yeah, we might have given it to Dr. Tweepak.
Huh.
So theta
think so.
equals just a random any number. Anyone have
What
any
were we saying?
suggestions for numbers?
For
It doesn't matter.
theta,
Yeah,
let's do a good.
I'm feeling 30.
Sure.
Easy. Yeah.
Yeah.
What I want, I'm gonna take this boiled water up to this pitcher, and meanwhile, you guys are gonna come up with the equation and like actually talk about how you're gonna do it using ropes and whatever.
Okay.
How are you gonna calculate this?
Okay.
thing?
Okay. And so we'll see. And what do you want to say is B? Little b. What's that distance? like 50 feet? 50 feet? 60 feet?
Maybe can I find what was shared with me? There was like can you find a doc shared with me?
Go for it, but we're just gonna do this. We can plug in the other numbers after. And so this would be 60. So that's nice. So then we want to find this one, little c, and then a, little a. So for that, how do you find little c again? You just need something that involves it, right? So you could do like the sine of 30, no. So yeah. No.
I'll be back. 2 minutes.
What involves the b in relation to big A? Would be like
36 to 90 is a lot easier to solve.
yeah. So wait. This is the cosine? Yeah, so it would be like adjacent. Okay. So the cosine of 30 equals what is it? C over no.
Would be adjacent.
Wait.
Yeah, it is adjacent.
So let's not do that.
Okay, so it's 50 over. So do you want to do the secant? No?
Do sine?
No.
Yeah, I thought you were talking about little a. So
Or
we can use.
do tangent.
No, okay, we need to
Opposite of
use.
adjacent.
Okay.
That's all we need is tangent. Tangent of 30 degrees equals a over 50.
Okay. No, tangent of 30 equals a over 50. Ta-da. Yeah?
Yeah, let me solve for that.
What I don't get is if you like plug in tangent 30 and you're gonna get like some decimal number, how do you like, how does it?
They were discussing you as a director upstairs as I
What?
walked in.
Oh my gosh, what the heck?
In complimentary terms.
My ears weren't even ringing, I don't get that.
All because they were
Wait.
saying the nicest thing.
Oh. What class was it?
I don't know. Jerry class? Theater class? I'm not sure. Oh, okay, let's see what you got. So the tangent of 30 would be a over 50. Okay, good. Now, then how would you find a?
That's what I was just asking Sydney. So you-
Hold on. So,
It's an equation, just work the equation.
multiply 5.57 times 50,
What?
right?
What's 0.57?
I agree with him, but you need to explain what you're talking about.
Because that's you find the tangent of 30 in degrees. So that'll be a numeric value, I guess, or like a value you can work with. So that would be 0.57 equals a over 50. So then you just multiply 50 times
Oh, okay.
that value.
Oh, I see. So it's 0.58
really.
is tangent 30 equals a over 50. Yeah.
Mhm.
And then you.
Yeah, you picked a great angle for theta.
Thank you.
So
I tried.
tangent. You may remember we talked about the equilateral triangles, the 30-60 90 triangle last time. And in the 30-60-90 triangle, it ends up where the ratios between them are 2, 1, and square root of 3. So the tangent of 30 is going to be 1 over square root of 3, which 1 over square root of 3 times 50 equals A.
Nice.
Yeah, in your thing. Okay, that's the math behind it,
So what we're gonna do
is make some measurements, right? But you have to make measurements. How are you actually going to go about measuring this and then measuring this? Because that's what you need, right?
So
We just need a flat surface. So I think we were able to get at least some length, some flat surface in the measurement there, and then we could just use it, take several measurements with the goniometer, like holding it up, or,
yeah, how do you like make it accurate though? Like
yeah.
I feel like it's really not that accurate. But like holding it like this, and just like eyeballing what angle Dr. K is at, isn't, how do you get it like, because that could change depending on like where I'm holding my arm.
Mm-hmm.
So what the heck?
Can you use a laser and strap a laser
So
to
what the heck?
Well, we do have that telescope there.
Ooh.
Let's use the telescope.
Okay.
The,
Why don't you guys think about it a little bit, and then I'll tell you my thoughts.
A equals 28.86751335 in this equation.
Okay.
What is it? Is it just the first one?
It's
That's the height.
A equals which now?
I didn't hear the number.
It was 28.
28. Yeah, that makes sense. So, yeah, the real thing that we've got going on here is if you were 50 feet away, and I think that's a great length. I think that's frankly a great length.
Like the best numbers.
50 feet away, and you are down this hill over here.
Yeah.
Right?
Yeah.
How are we going to do this?
I don't know.
What are some ideas?
We could use a leveler and a
Oh, that thing.
So we have a level. We do have
Yeah.
that thing that looks like this
Yeah.
Yeah,
or whatever with the like a level.
but also then we won't know exactly how many
What could we do to get this line? What do we have a lot of? We've got a lot of rope, string, stuff like that.
So you just hold it like that.
So you could tie a little piece of rope here and stretch it way out here, however long. Doesn't really matter how long, as long as you keep track of how long. Right? And then you put your little level on it to make sure that the rope is level. In fact, you'd want to do it on this end.
But what if we were in like the opposite situation where the flagpole was in a what are they called?
In a
A
valley?
valley, I guess.
Well, luckily it's not. But
But if it was,
but if it were, how could you do that? Let me think. If it were in a deep valley, you could do
it's smaller.
an angle of depression, right?
There'd just be like-
And then get this length, and then do an angle of elevation for this length and add them. So anyways, you put this here, you're standing just like this. Let's see, oh yeah, I just want to make this Sydney, give her a little ponytail back here. This is Sydney, don't take this the wrong way, I'm going to do the best I can do. And she's got her eyeball, and her nose, and her happy smile. Oh my God.
Sorry.
Sorry, Sid. And you're looking right along this. You have the goniometer giving you this angle. And this arm is lined up right with the length of that. You take the string, make a knot in it here and here, and then measure it out on the tape measure to get that length, and then you've got your angle. Yeah. Does that make sense?
I think so.
Yeah. I'll look at home. Maybe you did hand some of those numbers in. I'm not sure.
Yeah, I think you said because we all came up with our own ideas in our houses, and then I think you selected.
I know. I have to think about. I'll look for them. I'll see if I can find that stuff.
I thought we turned in something like with
Yeah.
numbers.
Yeah.
Yeah.
I remember we said something like 58 or 60 or something.
You like just turn them in. I don't know. Oh gosh, now I'm like second guessing myself whether anything was turned in or not. Because if it was, it would be like just the simple like numbers and like maybe that worksheet that you had us do, or not the worksheet, but like our work. You had us turn in that maybe.
Well, I will look for it up at home. It may be digital. Maybe I had you guys hand in something digital. Thank you so much for this. That was really sweet. My kids are gonna go. They're gonna have fun. Okay. All right, I think that's it.